You have been skipping breakfast, or eating your last meal at 6, or compressing every calorie you consume into an 8-hour window and spending the remaining 16 hours in what the content you follow has told you is a metabolically transformative fasting state. You have been told that the timing of your eating, independent of what you eat, independent of how much you eat, is doing something profound to your insulin sensitivity, your circadian biology, your cellular repair mechanisms, your metabolic rate, your body composition. You have been told that the clock matters as much as the calories, maybe more. I need to tell you about a study published in Science Translational Medicine, one of the most rigorous and selective journals in biomedical research, a publication that does not run small, poorly controlled studies, or accept work that has not been thoroughly peer-reviewed by experts in the relevant field. The study was called ChronoFast. It was led by Professor Olga Ramich at the German Institute of Human Nutrition in Potsdam and at Charité Universitätsmedizin Berlin. It was designed specifically to answer the question that every previous time-restricted eating study had failed to answer cleanly. Does restricting when you eat produce metabolic benefits independently of how much you eat? Every previous study on time-restricted eating had a fundamental confounding variable. When people compress their eating into a shorter window, they naturally tend to eat less. The eating window acts as a structural calorie reduction mechanism. There is simply less time available for eating, so less eating occurs. When these studies found metabolic improvements, better insulin sensitivity, lower blood glucose, improved lipid profiles, they could not definitively attribute those improvements to the timing of eating rather than the caloric reduction that the timing produced. ChronoFast fixed this. It was an isocaloric study, meaning calorie intake was deliberately controlled and held constant between the time-restricted eating group and the comparison group. The participants ate the same amount. The only variable was when they ate it. One group ate between 8 in the morning and 4 in the afternoon, early time-restricted eating. The other group ate between 1 in the afternoon and 9 at night, late time-restricted eating. Both groups maintained their habitual calorie intake for the full 2-week intervention period. The findings were direct and unambiguous. Neither the early nor the late time-restricted eating group showed clinically meaningful improvements in cardiometabolic health. Not insulin sensitivity, not blood glucose regulation, not lipid profiles, not inflammatory markers. When you hold calories constant and vary only the eating window, the metabolic magic that the wellness content industry has been selling you as the central mechanism of intermittent fasting's benefits does not materialize. The timing of eating did affect the body's internal clocks. The circadian biology was measurably shifted by changing the eating window, but those clock shifts did not translate into improvements in the metabolic markers that the time-restricted eating protocols have been marketed as specifically improving. The circadian argument, that eating earlier in the day, in alignment with natural light cycles and cortisol rhythms, independently improves metabolic function, was directly tested and directly failed to produce the effect in this controlled setting. The conclusions from the ChronoFast authors were precise. Calorie reduction plays the central role in the cardiometabolic health benefits of intermittent fasting. The timing mechanism, as an independent driver of metabolic improvement, is not supported by the controlled evidence. Now I need to be honest about what this means and what it does not mean, because the honest account of the intermittent fasting evidence is not a simple debunking. It is a more nuanced and, in some ways, more instructive story than either the enthusiastic advocates or the dismissive critics are presenting. The first thing to understand is the broader meta-analytic context that ChronoFast sits within. The 2025 BMJ Network meta-analysis, one of the most comprehensive analyses of intermittent fasting research ever published, examining dozens of randomized controlled trials, found that intermittent fasting diets produce similar weight loss and cardiometabolic risk factor changes to traditional calorie-restricted diets. Not worse, not better, similar. Intermittent fasting, across its various forms, produces genuine metabolic improvements when practiced consistently. Those improvements are real. The mechanism through which they are primarily produced is caloric reduction, not temporal magic. The meta-analysis from randomized trials found that intermittent fasting protocols yield approximately 1 to 4% body weight loss over 3 to 12 months. That is a real and clinically meaningful outcome for many people. But the analysis found no consistent edge over matched deficit diets that produce the same caloric reduction through conventional approaches rather than through eating window restriction. The outcome is equivalent. The mechanism is equivalent. What differs is the behavioral pathway through which the caloric reduction is achieved. This is actually an important distinction for understanding why intermittent fasting works for the people it works for. It does not work because eating between noon and 8 produces some special metabolic state. It works because compressing your eating window is, for many people, a genuinely effective behavioral tool for achieving a caloric deficit without the cognitive effort of calorie counting. If you only eat between noon and 8, and you were previously eating from 7 in the morning to 10 at night, you have removed approximately 5 to 6 hours of potential eating time from your day. For many people, this removes their breakfast and late evening snacking, two of the eating occasions most associated with habitual caloric surplus in observational dietary research. The protocol works as a caloric management tool, not because the fasting period is metabolically special, because it is structurally effective at producing the caloric deficit that actually drives the improvements. If you are among the people for whom 16.8 produces consistent weight management and improved metabolic markers, and there are genuinely many such people, the mechanism explanation I'm giving you should not change whether you continue the practice. It should change why you think it is working, and therefore how you troubleshoot it when it stops working. Because this is the point where the honest account of the evidence becomes practically important. If you believe that the timing of your eating is independently and powerfully metabolically transformative, and you hit a plateau in your weight or metabolic markers, you may focus on adjusting the window, making it tighter, shifting it earlier, extending the fasting hours, while the actual cause of the plateau is that the behavioral calorie reduction has stopped occurring. The window is the same. The caloric surplus has returned. And adjusting the timing will not fix a calorie problem. When intermittent fasting stops producing results, the question is almost always caloric, not temporal. Understanding this mechanistically means you troubleshoot correctly rather than chasing increasingly extreme timing modifications that the evidence says are not the active variable. Let me now address the circadian biology argument directly, because it is the most scientifically interesting aspect of the intermittent fasting literature, and the one that has been most overstated. The human body operates on a circadian rhythm, a roughly 24-hour biological clock that governs virtually every physiological process, including metabolism, hormone secretion, immune function, repair processes, and sleep architecture. This clock is real. Its influence on metabolic function is real, and the research on circadian misalignment, the metabolic consequences of eating, sleeping, and living in ways that conflict with the body's natural circadian rhythm, is genuinely compelling. Shift workers, who eat and sleep at times that conflict with their natural circadian biology, show elevated rates of obesity, metabolic syndrome, cardiovascular disease, and diabetes compared to day shift workers, even when total caloric intake is comparable. The circadian biology of metabolism is not fictional. Insulin sensitivity, glucose disposal, and fat oxidation do follow circadian patterns. They are highest in the morning and early afternoon, and are meaningfully lower in the evening and at night for most people. The question is whether restricting eating to an 8-hour window in the morning and early afternoon, early time-restricted eating, aligned with the period of peak metabolic function, produces measurable benefits in humans beyond what the same caloric restriction would produce at any other time. And here the evidence is considerably more modest than the content industry's certainty implies. ChronoFast tested early time-restricted eating specifically, the 8 a.m. to 4 p.m. window that the circadian biology argument says should be optimal, and found no clinically meaningful improvements in metabolic markers when calories were held constant. The circadian clock shifts were real. The metabolic improvements were not. This is not the final word on the question. The ChronoFast study was conducted over 2 weeks, which may be insufficient time for circadian alignment benefits to manifest. The sample, overweight women, may not generalize to all populations. The controlled setting in which caloric intake was deliberately maintained may not reflect the real-world conditions in which circadian-aligned eating is typically practiced. These are genuine limitations. but they are the limitations the evidence has. And the position that early time-restricted eating produces robust, independent, biologically meaningful metabolic benefits beyond what caloric restriction alone produces is not supported by the current controlled evidence base. It remains a biologically plausible hypothesis with compelling mechanistic rationale, but insufficient controlled human trial evidence to be stated with the confidence with which it is currently being stated across the content and clinical wellness space. The position the evidence actually supports is more modest. Early time-restricted eating may provide modest additional circadian benefits on top of the caloric reduction effects, particularly for metabolic timing-related outcomes, but the circadian benefit appears smaller and less consistent than the caloric benefit, and the caloric benefit is available from any form of sustained caloric reduction, regardless of timing. Now I want to tell you about the one form of meal timing that does have solid controlled evidence for specific cardiometabolic benefits, and it is simpler, more accessible, and more practically sustainable than any of the elaborate eating window protocols that dominate the intermittent fasting content ecosystem. The Northwestern Medicine study, published in February 2026 in Arteriosclerosis, Thrombosis, and Vascular Biology, the American Heart Association's flagship vascular biology journal, examined what the researchers called sleep-aligned extended overnight fasting. The intervention was specific and simple. Participants stopped eating at least 3 hours before their habitual bedtime and extended their overnight fast to between 13 and 16 hours. They dimmed lights and avoided food for 3 hours before sleep. That was the entire protocol. No specific eating window, no compression of meals into a 4 or 6 or 8 hour period during the day. Just stop eating meaningfully before you go to sleep. The results were specific and clinically meaningful. Compared to the control group that maintained their habitual eating patterns, the intervention group showed a 3.5% improvement in nighttime diastolic blood pressure dipping, the natural reduction in blood pressure that occurs during sleep in healthy individuals. They showed a 5% improvement in nighttime heart rate dipping. Their morning glucose tolerance improved, with the pancreatic beta cell insulin response being more efficient. And critically, the adherence rate was nearly 90% across the 7.5-week intervention period. People could actually do this and did do it consistently. Why do these findings matter? Because non-dipping blood pressure, the failure of blood pressure to drop appropriately during sleep, is an established, independent predictor of cardiovascular events and end organ damage. Research shows that each 5% increase in nighttime blood pressure dipping is associated with a 17% reduction in cardiovascular events. The sleep-aligned fasting intervention produced a 3.5% improvement in nighttime dipping. That is a small number in isolation that translates to a meaningful reduction in cardiovascular risk. The mechanistic explanation for why eating close to bedtime disrupts the natural nighttime cardiovascular recovery pattern is well grounded in circadian biology. The cardiovascular and metabolic systems require the quiescence of the digestive and metabolic processing systems to execute their nighttime repair and recovery programs. Eating triggers insulin secretion, sympathetic nervous system activation, increased heart rate and blood pressure, and the metabolic processing of ingested nutrients, all of which interfere with the autonomic and hemodynamic conditions that nighttime cardiovascular recovery requires. Eating close to sleep keeps the metabolic system in an active processing state at exactly the time it needs to shift into the recovery and repair mode that sleep enables. Crucially, the Northwestern study produced these benefits without changing caloric intake. The participants ate the same amount. They just stopped eating 3 hours before bed. This is the version of meal timing that the evidence currently supports most strongly, not because the timing itself has magical metabolic properties, but because it stops the specific interference with sleep phase physiology that late-night eating produces. This is the version of intermittent fasting adjacent practice that I want you to take from this video, because it has controlled trial evidence, a clear mechanistic rationale, high adherence, and no required changes to what or how much you eat. Do not eat within 3 hours of your bedtime. That is the entire protocol. No elaborate eating windows, no skipping breakfast or compressing your eating to a 4-hour afternoon window. Just finish eating at a meaningful interval before you sleep, and let your cardiovascular and metabolic systems run their nighttime recovery programs without the interference of active digestion. Now let me take a broader view of the intermittent fasting landscape and give you the synthesis that the evidence actually supports, neither the enthusiastic overclaiming of the advocacy community, nor the dismissive debunking of those who have responded to the ChronoFast findings as though they demolish the entire concept. Intermittent fasting in its various forms is a genuinely useful dietary tool for many people. It works primarily as a behavioral mechanism for achieving caloric reduction without the cognitive effort of explicit calorie counting. For people who find it easier to skip breakfast than to count grams of protein, for people whose eating is structurally improved by the decision constraint of an eating window, for people who struggle with late-night snacking and find that a closed eating window prevents it, intermittent fasting is a real, valid, evidence-supported approach to managing caloric intake. What it is not, and what the controlled evidence says it cannot be relied upon to be, is a metabolically transformative protocol that produces benefits independent of the caloric reduction it facilitates. The insulin reset is the calorie deficit. The metabolic reprogramming is the calorie deficit. The circadian optimization benefits, to whatever modest extent they exist beyond the caloric effect, are secondary and do not appear to be large enough to justify the elaborate protocols built around early eating windows in individuals who are already maintaining appropriate caloric intake. The practical synthesis is this: use intermittent fasting if it helps you eat less without requiring you to count every calorie. Stop pretending it is metabolic alchemy independent of energy balance. And add the one timing practice that the evidence most clearly supports. Stop eating 3 hours before you sleep, for the specific cardiovascular benefits that sleep-aligned fasting produces through a mechanism entirely separate from caloric restriction. The protocol that the evidence supports in 2026: eat in a way that produces appropriate caloric intake for your body composition goals, using whatever behavioral structure helps you maintain that intake consistently. Do not eat within 3 hours of your bedtime. If you find 16.8 useful as a calorie management structure, continue using it with clear understanding of why it works. If you find it creates unnecessary rigidity or stress around eating without producing better caloric outcomes than other approaches, there is no evidence that the timing protocol itself is essential. This is less exciting than being told that eating between noon and 8 is secretly reprogramming your cellular biology while you work. But it is what the research says. And the research, controlled, peer-reviewed, published in the best journals available, deserves to be communicated clearly rather than filtered through the narrative preferences of the content ecosystem that has built audiences around the more compelling version of the story. Now I want to address the autophagy claim directly, because it is the argument that the most scientifically sophisticated advocates of intermittent fasting reach for when the metabolic case starts to wobble, and it deserves a precise, honest treatment. Autophagy, from the Greek for self-eating, is the cellular process through which cells break down and recycle their own damaged or dysfunctional components. Organelles that are no longer functioning correctly, misfolded proteins that have accumulated and could cause cellular damage, debris from normal metabolic processes. Autophagy is the cellular housekeeping mechanism that clears this material and recycles the constituent parts for new cellular construction. The discovery of this mechanism and the identification of the genes that regulate it won Yoshinori Ohsumi the Nobel Prize in Physiology or Medicine in 2016. The research on autophagy is real, the mechanism is real, and its potential relevance to aging, cancer prevention, and neurodegenerative disease is genuinely compelling. The fasting autophagy connection is also real in its basic biology. Autophagy is upregulated by cellular nutrient deprivation, when the mTOR pathway, which senses nutrient abundance, is inhibited by the reduction of circulating amino acids and glucose that fasting produces. The cell shifts resources toward autophagy and cellular maintenance rather than growth and protein synthesis. This is established cellular biology. What is not established, and this is the critical point where the enthusiasm has dramatically outrun the evidence, is the translation of this cellular biology into clinically meaningful human health outcomes through the specific fasting durations that the 16-8 and similar protocols employ. The fasting periods in standard intermittent fasting protocols are 14 to 16 hours. The research on autophagy induction in human tissue, specifically the studies that have actually measured autophagy markers in humans rather than in cell cultures or animal models, suggests that meaningful autophagy upregulation in human beings requires considerably longer fasting periods than a standard overnight fast, followed by an 8-hour eating window produces. The studies that demonstrate robust autophagy induction in humans have typically used 48 to 72-hour fasting periods, not the 12 to 16 hours that 16.8 produces. Some research shows modest increases in circulating autophagy markers in humans after 24 hours of fasting. The specific claim that a 14 to 16-hour overnight fast reliably produces clinically significant autophagy in human beings. The claim that underlies much of the mechanistic case for 16.8 as a cellular health intervention beyond its caloric effects does not have strong controlled human evidence to support it. This does not mean the autophagy argument is complete fiction. The cellular biology is real. Extended fasting does induce autophagy. Whether the specific duration and frequency of standard intermittent fasting protocols produces autophagy induction at a magnitude that generates clinically meaningful health outcomes in humans, as opposed to in cell cultures, in animal models, or in humans undergoing dramatically more extended fasting periods, remains genuinely uncertain and is being significantly overclaimed in the content ecosystem. The honest position is, autophagy is a real mechanism with genuine potential relevance to human health. The fasting durations used in standard intermittent fasting protocols may not reliably produce it at clinically significant levels in humans. The evidence base for claiming that 16.8 produces meaningful autophagy benefits in humans is much weaker than the confidence with which that claim is made. I also want to address the individual variation question because it is one of the most genuinely important and most underappreciated aspects of the intermittent fasting literature. The aggregate findings, that calories explain most of the benefit, that the timing mechanism is secondary, are population-level conclusions drawn from group averages, and the research on individual variation in responses to different fasting protocols is real and clinically relevant. Chronotype, the genetic and behavioral tendency toward being a morning person or an evening person, meaningfully influences how the body responds to the timing of food intake. Morning chronotypes, whose cortisol peaks, body temperature rhythms, and metabolic activity patterns align with early parts of the day, may benefit more from early time-restricted eating protocols that align with their natural biological schedule. Evening chronotypes, whose peak metabolic activity occurs later in the day, may find early eating windows are actually working against their biology rather than with it. A significant body of research shows that forcing an early eating window on an evening chronotype, telling a person whose natural peak cortisol and mental acuity occur at 10 at night to eat only between 8 in the morning and 4 in the afternoon, may not produce the circadian alignment benefits it would produce in a morning chronotype, and may actually produce circadian misalignment that negates or reduces whatever modest timing benefits might otherwise exist. The individual variation research also shows meaningful differences in how people respond metabolically to the same fasting protocols based on their baseline insulin sensitivity, their gut microbiome composition, their age, their sex hormones, and their baseline metabolic health status. The 2025 ChronoFast study was conducted specifically in overweight women, a population with specific metabolic characteristics that may not generalize to lean individuals, to men, to younger populations, or to people with different underlying metabolic states. This means the conclusion is not that intermittent fasting never produces timing-specific benefits for anyone. The conclusion is that the population-level controlled evidence does not support the claim that meal timing produces robust metabolic improvements independent of caloric restriction across the general population. For specific individuals, particularly morning chronotypes with elevated metabolic risk, early time-restricted eating may produce modestly greater benefits than the same caloric restriction achieved through other means. The evidence does not rule this out. It simply cannot confirm it with the confidence that the content ecosystem has been using. The practical implications of taking individual variations seriously are this. If you have been practicing intermittent fasting and experiencing genuine benefits that seem to go beyond what you would expect from caloric restriction alone, if your energy is better, your cognitive clarity is sharper, your mood is more stable when you eat in a particular window. That subjective experience is information. It may reflect genuine individual biology that the population-level data averages over. Do not abandon a practice that is working for you because a controlled study found it did not work on average. Use the evidence to understand the mechanism, not to override your own experience. But conversely, if you have been practicing intermittent fasting with strict adherence to the timing protocol while not seeing the results you were promised, if the insulin sensitivity reset and the metabolic reprogramming and the cellular renewal have not materialized in your experience and in your markers, the evidence suggests that the timing itself may not be the active variable you have been optimizing. The active variable is calories. And if the window has not been producing a meaningful caloric deficit, the window has not been producing the benefits. Let me bring this to a complete practical synthesis. The evidence supports intermittent fasting as a valid dietary tool for caloric management. It does not support intermittent fasting as a metabolic intervention that independently produces significant benefits when calories are held constant. The sleep-aligned overnight fasting practice, stopping eating 3 hours before bed, has specific controlled trial evidence for cardiovascular benefits through a distinct mechanism involving nighttime autonomic function, and it requires no changes to eating window duration, caloric intake, or meal composition. It is the single meal timing modification with the strongest and most specific controlled human evidence for benefits beyond what caloric management alone produces. The broader framework: use whatever behavioral structure helps you eat appropriately for your body composition goals. Stop eating before bed. Track your actual results rather than your timing compliance. And communicate clearly with yourself and others about what the practice is actually doing, rather than what the most compelling version of the story says it is doing. The clock matters a little. The calories matter a lot. The 3 hours before sleep matters specifically and has controlled evidence. Know which is which and build your practice on the right foundation.